so we're going to start out by looking at section 4.5, and we're going to split it into two parts. Yeah. This I know. So we talked a little bit last week, and in the warm-up we just did, about looking at a scatter plot and finding a line that goes through a set of points. Last week we just kind of estimated. Okay, we had some points, we just drew a line in the best we could, and that's okay. But sometimes you want to find like a really good line, like the best line that you possibly could. You can do that by hand. There's some formulas, it's a little bit beyond what we do in Algebra 1 to do it by hand. But we're going to use a tool that can do it for us. And we'll look at that in a little bit. Now, another way to look at how good of a line you drew through points is to look at what's called a residual. Okay, and I'm going to show you a picture. It looks like kind of a fancy word. It's really pretty simple. I'm going to show you a picture of what a residual is. So here's the definition first. And you've got your first point on your guided notes. You just have a couple blanks to fill in. So it says, for the first blank, a residual is the difference. So it's a subtraction problem. That's what a residual is. You have to subtract two numbers. What two numbers do you subtract? It's the difference between the y value, so that goes in the next blank, of a data point, and the y value using the line of fit. So the line of fit, that's the line that you draw by hand. So let's take a look at the picture. Do you guys already have that picture on your notes? Yeah. Okay, perfect. All right, so these black dots represent 4 points. And somebody tried to draw a line through them. Whether you think that's a good line or a bad line that they drew, we're not worried about it. But that's the line that they drew through those points. I would say maybe if you had some more points, maybe some up here, and another one over there. Now I could say it's definitely going up and to the right. But with only these 4 points that they had at first, I don't really know if that's a positive correlation, but that's how they do it. All right, so here's the data point. That's an actual point that they gave you in the problem. This is where you put your line. How far away your line is from the actual data point, that's called a residual. So the lower a residual is, the better. That means the line is very close to the point. And that's the idea. This line should be as close as you can to all the points. Like right here, this is a very small residual. The distance between the data point, which is the actual point they gave me, and my line that's an estimate, is pretty small. It's very small. It's just a little bit above it. When your data point is a little bit above your line, that's called a positive residual. When your data point is below the line, that's called a negative residual. And the idea is you want the residuals to be pretty small. All right? Like if you drew a line like this, let's just say your line is like way down here, I would say that is not a very good line going through those points because all the residuals are pretty big. Like if you count the distance, 1, 2, 3, 4, 5, that point's almost 5 units away. If you count this one over here, that's 1, 2, 3, like 4 units away. And every residual to that red line is positive. You should have a balance. Some positive and some negative. That means your line is right in the middle. If they're all positive or all negative, that probably means your line isn't in a good spot. Okay, so that's all that a residual is. It's the distance between your data point and the line that you estimated. Smaller residuals equals better. Big residuals, you didn't draw that good of a line. Now, the next thing says, this is your second bullet, a residual can be positive, negative, or zero. If the data point's above the line, that's a positive residual. If it's below the line, that's a negative. How do you think you'd get a zero residual? Where do you think the data point would have to be? Yeah?
Would have like cross the whole.
Well, we don't have an axis. We don't really have an x or y axis here, so we don't have an origin really in this picture. But how do you think you'd get a residual that's zero? Yeah?
If it were just a straight line.
Well, this is a straight line, right? This black one. It's not curved or anything like that. So remember, the residual is measuring a distance, yeah? It's possible. Well, if you had one that was vertical, then you wouldn't really be able to have points above or below the line, because you could have points left and right of it, but it's got to be either horizontal or slanted. So we'll never have one that's vertical. Yeah? Exactly. If you had a data point like this, and that was one of your actual data points, and your line goes right through one of the data points, then that means the distance between the line, which is the estimate, and your point, which is the actual point, they're right on top of each other. There's no distance between them. Right, so that's an example of a zero residual. It's right on the line. Above is positive, and then below is negative. So what we're going to do is we're going to make a table, and you'll have the same kind of thing on the test and on a worksheet later in the week that shows me all the residuals for the points in the scatter plot. All right, so this is basically the table that we're going to make. And you know what? I think we're going to make it horizontal instead of vertical. So let me actually switch that. Okay. There's some bullet points down below, but you guys are you're gonna put those in after. Okay, so our table is usually gonna look like this. So we'll have an X and a Y. Those are gonna be from the data they give you. Like if you were making a scatter plot, that's the coordinate. The next row is Y value from the model. So the model is the line that you drew. It's kind of like it's like your estimate when you put your line in. And then the last row will be the residual. That's going to be the distance between the actual point and the line you drew. And you're going to have as many columns in the table as you do points. Because you have to do this table, or you have to make a column in this table for every single point on the graph. And since I changed it a little bit, I'm just going to change this to rows. So your first bullet should say the X and the Y rows come from the data in the problem. So to fill out, we'll call this row 1 and 2. There's no calculation. You don't have to do any math at all for rows 1 and 2. Row 3, that's the Y value from the line you drew. Remember, it might not be exactly the same as your data point. It might be off a little bit because it's an estimate. So the second bullet point should say the y value from the model is the y value you get when we use the line, or when we plug into the formula for the line. How do you find the formula for the line? That's what we did in the law. You have to find the slope. You have to find the y-intercept. Now, sometimes they may give you the model. If they give you the equation, then you don't have to worry about finding the slope and the y-intercept. They may just give it to you. I think in the first problem we do, they're going to give you an equation that models the data. So x and y rows come from the data in the problem. The y value from the model is a calculation you have to do by plugging into a formula that I think most of the time they're going to give you. Okay. And then the last, I think this is the last bullet you have, there should be 3 of them, is how do you find the residual? So I just numbered the rows. The residual is found by looking at the difference between the data point they gave you and what the formula predicts you would get when you draw in that line. Row 2 is the value that they give you. Row 3 is the estimate if you used your line that goes through the points the best you could. Yeah.
I love that.
Yeah. So what I'm going to do for the first problem is I'm actually going to do an example that we did in the last section. You don't need to take out your guided notes from 4.4. That was the last section. I'm going to copy it down, and I think it's already on your guided notes for you. Okay, does everybody have those 3 plots? And you could do this as a row, or you could do it as a column. But I think the book, if you look at our book, they do it this way. It's the same thing, except I'm going down, they go across. It's still the same idea. Okay, and oh yeah, you guys have one more line below that last bullet. Because a table can be kind of hard to look at, what we're going to do is a lot of times we're going to take all the residuals and we're going to put them in a picture. We're going to make a graph of all the residuals. So then we can see how big or small they are in a lot easier way than looking at a table. Yeah, a picture I think is always easier to see than a table. And in that last step, the points we're going to graph are x. That x is going to come from whatever number is right here. And then the second thing it says is residual. And that's going to come from whatever number is right here. So when we're done, we're going to be looking at those 2 things. What did we have for an x? And what did we get for a residual? That's what we're going to focus on. All right. Now, what did I say earlier? When you draw your points and you put in a line the best you can, do you want the points to be pretty close to the line if you did a good job with it? Or should the points be really far away from it? Yeah? Yeah, the points should be really close. We want these residuals to be as small as possible. If they're really big, then that means your line is not close to the points, and that's not what we want. We want a line that's nice and close to the points. All right. Try an example. So this is an equation that I'm getting from a problem we did last week. Do you guys have the formula negative 2x plus 20 on your guided notes? Yep. Okay, perfect. So this equation is going to be the formula for the line that goes through the points. Now, how would you figure this out? Well, there's two things, right? There's this number. What's the number that I'm pointing to in that formula? What's that? Well, what's that number called? Yeah, that's the slope. And what about the number I'm pointing to at the end? Yeah, the y-intercept. So if you didn't have this equation, you would have to figure it out just like we did in the warm-up. You'd have a bunch of points. You'd draw your scatter plot, take a ruler, draw a line the best you can, and then figure out your slope and your y-intercept. So just to do that step, that could take a couple minutes just to figure that out. But in this problem, you don't have to figure it out. They're giving you the equation that you would have gotten by doing all that work you did in a warm-up. All right, so let's make a table. You guys already have a table on your guided notes. So let's start to fill it out and see what we get. Now, I think I switched it. Yeah, so the x and y go the other way. So I'll just draw the table myself. All right, so we got x, y value from the model, and the residual. Okay, let's put some lines in there. Again, you guys are going to have a table already filled out like this on the test. You're not going to have to draw your own table. Okay, I'm not sure how many we need, but let's see. All right, let's start with our first x value. The x and the y values are basically coming from this table. So this is some problem about how many weeks had gone by and how many sales. I think it was about a movie. Like after week 1, how many sales were generated by the movie. And then the longer the movie was out in theaters, it didn't generate as much money because people had already seen it. So it started to drop. All right, so what does it say for week 1 our sales were for the movie? Yep. 19. And what is that? What do the sales represent there? Millions. So yes. Week 1, the movie made 19 million. How much money did the movie make week 2? Yep. 15 million. So it's dropping a little bit. How about week 3? Yep. 13 million. All right. And then week 4? Yep. 11 million. I think I might need a couple more lines here. That over. All right. How about, can't see it. Let me move the table. Sorry about that. How about, well, that's the best I can do. How about week 5? What were the movie sales in week 5? Yep, 10 million. How about week 6? Movie sales, Abby? Yep, it's dropped to 8 million. How much did the movie make on week 7? Yep, 7 million, so it just keeps going down at this point. And how about the last week, week 8? Yep, made 5 million. So when I say to you rows 1 and 2 in this table are from the data, that's what I mean. You don't have to calculate anything. All right, now, we're going to pretend like somebody took all these points, they made a scatter plot, and they drew a line to the points the best they could, and they found the slope and the y-intercept for you, and that's what they came up with. So that's the formula for the line that goes through those points. To get the y value from the model, you're going to take each x value and you're going to plug it into that formula that they gave us. So we'll take each x value one at a time, plug them into the formula, and see what we get. Okay, so whoever did this thinks that this formula should predict how much money the movie is going to make each week. And it might not be perfect, but that's what we're going to see. Okay, so what's our first x value in that table? Yeah? 1. So you're going to take the 1, and you're going to plug it into the formula, and you're going to put the answer right here, where it says what's the y value you get if you use your model, which is your formula. All right, Caleb, what's -2 times 1?
-2.
Yep. And what's -2 plus 20?
18.
18. So this is the actual money that the movie made. This is how much money the formula predicted the movie would make. I'd say that was pretty good. It was pretty close. It's a little bit off, but it's only 1. That's not bad. Now let's plug in 2. Joe, if I plug 2 in for x, what's -2 times 2?
4.
That's 2 times 2.
Divide.
No, multiply. -2 times 2. Yep, -4. And Emily, if you do -4 plus 20, what do you get? 16. Okay, let's look at that one. The movie actually made 15. The formula predicted we would make 16. Was that pretty close? You think? Yeah, you think it's pretty close? Yeah. So as Alyssa said, it looks pretty close. It's only 1 off. That's not bad. All right, let's check the next one. Week 3. Plug in 3 for x. Dorian, what's -2 times 3?
That would be -6.
And what's -6 plus 20?
14.
14. All right, so the formula predicts we should have made 14 million. We actually made 13 million. The difference between the two is the residual. That's what we're going to do next. So small residuals are good. All right, Natalie, for week 4, if we plug that in for x, what does the formula predict we should have made? So -8 and then plus 20.
12.
Yep, that's going to be 12. Okay, so I think that's pretty good. All right, let's try week 5. Mia, if I plug in 5 for x, what's -2 times 5? -10. And what's -10 plus 20? 10. How about that time? Did the formula make a good prediction for the value the movie should have made? Yeah, it predicted it exact. So that's as perfect as you can get. The prediction matches exactly how much money it actually made. All right, week 6. How about Finn? What's -2 times 6?
-12.
And what's -12 plus 20?
8.
8. Again, another really good prediction. The formula predicted the exact amount of money that you should have made. Okay, let's try week 7 with the formula. Lexi, what's negative 2 times 7? Negative 14, and then plus 20. That's 6. All right, so not bad. The formula was a little bit off this week. It predicted 6 million. The movie made 7 million. But that's not bad. It's pretty good. And then week 8. Negative 2 times 8 gives me how much? Yep. And what's negative 16 plus 20? 4. Okay, again, not bad. Another pretty good prediction. Now, we kind of were doing this as we went along, but I was asking you guys how good the prediction was. That's what the residual is. How far off is the prediction from the formula from the actual result? So let's go back and look at how it says to do that. The residual is found by doing row 2 minus row 3 for each one. Remember, small residuals are good. That's what we want. So now, row 2 minus row 3. Let's start. Anaya, what's 19 minus 18? 1. That's how far off it was. It was 1 off. Okay, the next one. What's 15 minus 16? Oh, Micah? Sorry, Mike. Negative 1. All right, so that one was also 1 off, but it was 1 too high. The week before was 1 too low, but they're still 1 off. All right, the next one, 13 minus 14 gives me, yep, negative 1. Okay, the next one, row 2 minus row 3. What's 11 minus 12? Okay, so again, the prediction was 1 too high. That's why we got this residual. 10 minus 10, yep. 0, that's a residual of 0, which means your line is perfect right there. It goes right through the data point. How about week 6? What's the residual? Yeah, it's also 0. Week 7, what's our residual there? Yep, 1. This time the prediction was 1 too low. We actually made a little bit more money than the formula predicted. And then what about my residual for week 8? Yep. 1. Yep, 1. Again, the prediction was a little bit low. We did a little bit better than the formula predicted. Okay, and that's everything that you should put for the table on the left. Yes? Yep. Okay, does everybody have that table filled in? Okay. Now, what we're going to do is make a picture of the residuals, and that's going to basically show us how far away they are. So remember what your picture looks like. The points on the plot that we're going to make are x, comma, residual. So you're looking at, if I just kind of highlight what you're looking at, here are your x's. Here are your residuals. Those are the 2 rows we're going to focus on to make the picture. This number, comma, that. So x, comma, residual. And we're going to do that for each column. Okay, what's my first x value? 1. And what's my first residual? 1. So we're going to graph the point 1, 1 on this picture. 1, 1. Good. Okay. Let's see if I can get all this on the screen at the same time. What's my next x value? Jacinda?
2.
2. And what's my next residual?
-1.
So 2, -1 goes right there. Oh, wait. Did I do that one? I'm going to fix. I don't like how this is numbered. Let's go. This will be 0, 1, -1. I don't know why they were going by 0.5s in that picture, but let's just go by ones. That's easier. So 1, 1. That looks good. And then 2, -1. Right there. Yeah. Yeah. Okay. What's my next x value? You could just type it. Yep. 3. And what's my next residual? -1. Okay, so 3, 1, 2, 3, down 1. Perfect. What's my next x value? Oh, John? My next x value? 4. And my next residual? Okay, 4, -1. That looks good. Okay, my next x value? Yeah. And the residual for that one?
0.
5, 0. It's perfect. Okay, it's right there. My next x value? Yeah. 6. And the residual?
0.
That one's 0. That one was perfect. Okay, Hanukkah, my next x value?
1.
We did 1. We just did 6. So yeah, 7. And what's the residual?
1.
Yeah, so 7, 1. And my last x value? Yeah, 8, 1. All right. Now, to answer the question, is this model a good fit for the data? This is what we call a graph of the residuals. You want the residuals to be pretty small, like 1s, -1s, that's good. If the residuals start hitting like 5s and 6s, that's not as good. So what do you think here? If I just kind of make this bold, here's your line at 0. Are all the residuals between 1 and -1 in this case? Okay, get it? Yeah, they're all between 1 and -1. And ideally, you want as many residuals above 0 as there are below 0. That means that your formula made an equal number of predictions that were too high and an equal number that were too low. It was right in the middle. If every single residual came out positive and you didn't have any negatives, then that would mean your formula is kind of lopsided. Every single prediction in your formula would have come out too low. If every single prediction is too low and it's not balanced with some that were too high, then you probably didn't draw a good line. Okay? But that's called a plot of the residuals. In this case, I don't really think we needed the plot. I could pretty much just look at this row and say, oh yeah, all the numbers are between 1s and -1s. They're pretty small, which tells me that it was a good fit. Okay.
Mr. Hager, at
Yeah.
this point, you just want the class of the line, you're not looking for an actual line, you know, or anything like that.
No, just something that looks just like that. Well, actually, just like what we did right here. That's perfect.
Thank you.
Yeah. All right, let's try this one. So this is a word problem that says table below shows the age and salaries of 8 employees in a company. So the first step is somebody would have taken all these points, made a scatter plot, drew a line by hand, and then found the slope, like we did in the warm-up, and then estimated the y-intercept. And when they did all that work, this is the formula they got when they drew a line through those points. what we're going to do is figure out, did they draw a good line? So hopefully we're going to look for residuals that are small. So let me, I need to set up my table. Actually, I can just click this. Let's get rid of that. Okay. So you guys tell me, what's the first row in the table? Like what's going to go on the left-hand side? The first row is the... Yep.
X.
Yep. It's the X. What about my second row? Yeah.
Y.
Y. The third row? Yep.
Y value from model.
Yep. So this is the prediction. This is what the formula predicts we're going to get. The row above it is what we actually got. So Y value from model. And then what do we call the last row that says how good the prediction was? And we hope this is a small number. Yep. The residual. Okay, so let me just make a table. And how many do I need? 1, 2, 3, 4, 5, 6, 7. I need 8 of them. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. You're not going to have to do this for more than 8 points, because if you start getting into like 50, 60, 70 points, it's going to take forever. So, 8 points, 9 points, that's a good amount. Okay. Are there any calculations we need to do for the X and the Y? No. Where do we get these X and Y's from then if we don't have to calculate them? Where do they come from? They come from the table. X, in this case, is age. And Y, in this case, is salary. Right? So can somebody tell me, what are my X values that I'm going to fill in the top row? Yep.
35, 87, 41, 43, 45, 47,
7, 53, 55. Perfect. And then the Y values are all the numbers that are below. So those are the salaries. And again, the salary, that's not like $42 a year. That's the salary in thousands. So like this person who's 35 makes $42,000 a year. All right, so let's fill those in. 42, 44, 47, 50, 52, 51, 49, 45. Okay, there's a lot of copying there, so you want to double check if you notice a mistake. Just let me know. All right, and now let's do the Y value from the model. Okay, so to do the Y value from the model, what's the first number that I'm going to plug in for X? Yeah, 35. Right? Because there's a decimal here, I want to use my calculator. So I want to do 0.2 times 35. And then I'm going to do plus 38. So we get 45. That's our first one. Finn, what's the next Y value I'm going to plug in?
37.
Yep. See if I can do it all at once. 0.2 times 37 plus 38, and that's 45.4. Okay, that's why we needed a calculator. So 45.4. Abby, what's my next X value?
41.
41. So nice thing about this calculator, I can just bring up the last thing I typed, change one, just change it to 41, and I get 46.2. Okay. How about Brady? What's my next X value?
Next would be 43.
43, and we get 46.6. All right. Maya, my next X value?
45.
45. Okay, let's plug that in. We get 47. Ooh, that's not a really good one. All right, my next x value. Emily? Yep, 47. Formula predicts we should get 47.4. This isn't really looking that good this time. Lexi, what's my next x value? 53. And the formula predicted there, 48.6. That one's pretty good. And Dorian, my last x value?
55.
So let's do 55. We got 49. Okay. So now, let's find the residuals. Remember, ones and negative ones are kind of what we're looking for. What's 42 minus 45? Yep.
-3.
-3. So the prediction this time was 3 units off. It was too high. Yep. Yeah. Okay. The next one is 44 minus 45.4. Okay, that was -1.4 off. Not bad. All right. The next one is 47 minus 46.2. That one I can just do in my head. That's 0.8. Right. The next one is 50 minus 46.6. 50 minus 46.6. 3.4. What do you think of that one? Was that a good prediction? Joe, what do you think?
No.
No, it's 3.4 off. Remember, we kind of want to stay between 1 and -1. We're getting a little high there. Right? The next one, 52 minus 47. What's that come up to? Yeah? 5. Well, that's not good. So that one was 5 units off. Okay. Next one, 51 minus 47.4. And another one that's over 3 units off. 49 minus 48.6. That one's going to be pretty good. But the thing is, you want them all to be pretty good. You don't want some of them good and some of them not as good. So that's 0.4. And the last one, what's 45 minus 49? Yeah? -4. And another one that's not that good. So just by looking at the residuals, I can kind of tell they're not that great. Okay, they're definitely not as good as they were in the last problem. The last problem, they overall were much smaller. All right, so let's graph. Highlighter. So you're going to focus on this and that to make your residual. Okay, what's the first point that I'm going to graph on my plot for my residuals? Yep.
35 -3.
Okay, so 35 -3 to me looks like it's right about there. Looks like it goes by 5s. And they're skipping 0 to 30. That's why they put that little symbol in. Okay, what's the next point? Yep.
37.
Okay, 37 -1.4. Just an estimate. That's good enough. All right, what's the next one? Yeah.
41 and 40.
41 and then 0.8, maybe right about there. Okay, let's see, the next one? Brady?
Next one would be 50.
43. Yeah.
43 and 3.4.
43, 3.4. Yep. That one's way up here. This is not good. Those points are way spread out. They should all be grouped together very close. All right, the next one is 45.5. That one's even worse. 47, 3.6. So maybe about up there. 53.4. That's a good one. All right, 53.4. And then 55 down 4. Not good. So look at this line that I just drew in black. The closer the red dots are to that line, that means the smaller the residuals were. Are the red dots close to that line? What do you think? Senda, what do you think? What do you think? Are the red dots close to that line in black that I drew?
Not really.
Not really. Compared to the last one. Look how close those are. They're all really, really close. That means the residuals were small. That's good. Here, those red dots are spaced way out from the line. Some of them up to 5 units away. That's bad. So, to answer this question, is this model a good fit for this data? I would say no. It's not. It's not a good fit because the residuals are too big. Maybe we can find a better line. Maybe we can't. I don't know. So any question on making that table, then drawing it out for the residuals, and answering this question? All right, so, for today, I'm going to do something with the calculator, and I'm going to do it with this problem, just to show you. And then I think tomorrow, that's the part during the warm-up. I'll let you guys try the same thing on the calculator. So that last bullet that I'm going to have you guys fill in for today, it says graphing calculators use a method called, and then you have a blank line. On that blank line, I want you to fill in linear regression. That's a fancy word that basically means the calculator is going to find the best possible line that goes through a set of data. You're not going to draw a line and try to estimate the slope and the y-intercept by hand. The calculator is going to do it for you. And then it says, what do you call what you're finding? You call it a line of best fit. When you draw it by hand, it's called a line of fit. It's not necessarily the best one. It's the best one that you estimated using your eye. This is the one that's the best possible line, period, calculated with a formula. We're not going to learn how to do it by hand. It's a little more than what we would do in this class. Right? But it's the best possible line that you could have. All right, so let me go back to this set of data, and let me show you, just so you can kind of see what it's going to look like on the calculator when you do this tomorrow. I will write down the steps for you when we actually do a problem. Let me show you what it's going to look like. So when you just turn the calculator on, that's the first thing. You got the button that's on in the lower left. Okay, very similar to the ones that you guys use on a test. At this screen, you can just do like basic arithmetic. You can add, subtract, multiply, and divide. What I want to do is I want to put all these points into the calculator. And there's a place that has a table in the calculator that you can put all those points in. And it's under what we call stat. Because when you find a equation, find an equation. You're doing something that's called statistics. So that's why the button that we're going to have to press, and I'm going to write it down, is called Stat. And what we want to do is edit the list. I want to edit some numbers. Now, when I click Edit, I've already got numbers in there. So if somebody else used this before me, put these numbers in. I'd like to get rid of them, so I don't have them in there. And if I press the Delete button, it gets rid of them all. I got to keep pressing it until they're all gone. But now there's nothing in the calculator. The first thing we do is we put in all the x values into this calculator. And the way we're going to type them in is just like this. 35, and then we hit Enter. And we do it for all of them. 37, 41. This is probably the longest part of the whole thing. So we put all the x's in first, and then we want to put all the y's in, but we want to put them next to it. So we got all the x's on the left. I press my right arrow, and now it's going to let me put all my y's on the right. 42. So this is exactly what you guys are going to do tomorrow. 47. But it just helps if you see one done first. And then when you try to do it, you'll have the directions and you'll have already seen me do one. 52, 51, 49, and 45. Okay, so everything that we need now is in the calculator. You don't have to save it, it's already saved. What I need to do now is to tell the calculator to find that line. I want the calculator to figure out a slope, and I want it to figure out a y-intercept. And that's the last step. To tell the calculator to actually do something with all these points, we're going to press Stat again. But we're not going to go back to Edit. If you made a mistake, you can go back to Edit and you can change one of those numbers. But I don't think we made any mistakes, so we're just going to leave it. We're going to press Stat, and this time we want to calculate something. What we want to calculate is a y equals mx plus b formula. So I'm going to press the right arrow, and one of these options should look like y equals mx plus b. There's a lot of them. And if you're not sure which one looks like y equals mx plus b, keep this in mind. Linear regression. Does anybody see one of those options that maybe has an abbreviation for linear regression, and then in parentheses next to it, it says like something x plus b? They may use a different letter, but that's okay. Yeah?
4.
Yeah, it's the fourth option. All those other options do other things, which we're not even going to look at. So we're going to press the number 4 for the fourth option. At this screen, we don't have to do anything. All we have to do is press Calculate, and it's going to give me a formula. Let's see what it gives me. All right. So the first thing is it tells you what type of formula it just gave you. That's y equals mx plus b. I know it says a, but the calculator uses a, we use m. What value did the calculator give me for a? Yeah? Yeah. Yeah, and we can round that up. We can say it's about 0.2. It's exactly the value that this person got when they did the formula. So whoever drew this line when they did this problem, they did a good job finding the slope. 0.2 is what they should have gotten. And b is the y-intercept. What did the calculator tell me the y-intercept should have been? Roughly. Yeah?
38.
The calculator said it should have been 38, and the person who did the formula got 38. So the person who found this formula did a really good job. The problem, let me just move this. The problem is not with the formula. The problem is with the data. This is probably data that it doesn't have a good correlation. It probably, if you were to graph this data, it probably doesn't look like it's in a straight line. So even if you do a really good job finding the line, which this person did, it still doesn't guarantee that it's going to work well if the data doesn't line up in a straight line. Okay, and it doesn't. And that's it. That's all there is to calculating what's called a linear regression. So let me put the steps up. I'm not going to have you guys practice it today, but we'll practice it tomorrow. But at least you'll have the steps. Okay. Do you guys already have steps 1 and 2 written? Yeah. Okay. So you've got that. I'm just seeing if there's anything you need to fill in. Do you guys have step 3 written down? Okay, so you've got that. So actually, I think you guys already have the steps. Yeah, so that's good. So what we'll do tomorrow in the warm-up is we'll take all this data, we'll put it into the calculator, and see if you guys can do what I just did with the last problem. And I'll help you out. Okay, so tomorrow we'll just practice the calculator, and then we'll do a little bit of review. Okay, so the homework tonight is a worksheet on 4.5 part 1. Now, listen carefully. On the worksheet, the problem that has the residuals, you will be finding. There is a problem on the worksheet, I think, that says use a graphing calculator to do something. You probably don't have a graphing calculator at home. Don't do the graphing calculator problem on the homework. Just save it. And we're going to do it in class as part of the work. So don't worry about anything that says use a graphing calculator to find a line of best fit. We will do it together tomorrow. Okay?